Hello and welcome to this MVA course where we're going to look at the virtualization capabilities of Windows Server 2012 R2. My name's Matt McSpirit. I'm one of our technical product managers in the Windows Server and System Center teams. And we've got a whole host of cool technologies to discuss today that we're really going to arm you with useful information about our virtualization capabilities. So let's take a look at the agenda for today. Now, as you can see, we've got a packed agenda where we're going to look at the scalability and performance first after an initial introduction. And that's going to look at some of the key scale numbers, the ways we can generate high performance for our key virtualized workloads, and some of the key features that enable and unlock that, especially some of the integration we have with our hardware partners. We're then going to move on and look at some of the security and multi-tenancy capabilities that enable us to provide an isolated, secure environment for our virtualized workloads, and also talk about some of the encryption capabilities we offer as part of Hyper-V and Windows Server as well. We'll then move on to our flexible infrastructure, how we can start to provide a comprehensive platform for not just Windows but Linux workloads, and also how we can start to move workloads around that infrastructure flexibly with some of the new capabilities we've introduced specifically in R2. We'll then start to wrap up with some of the HA, the high availability and resiliency sections, where we'll look at how we make our mission critical, our important workloads highly available. If we're putting lots of eggs in fewer baskets, we want to make sure that things are resilient. And if we lose a physical Hyper-V host, what happens to those virtual machines? What happens if we lose a site? How can we account for those kind of things? We're going to cover that in the HA and the resiliency section. And then we're going to wrap up with a look at some of the other innovative capabilities that are within Windows Server 2012 R2, specifically around making virtualization better, making it more usable, more rich and more capable in terms of some of those key features that we'll explore. And then we'll wrap up with a summary and some of the key call to actions as well. So without further ado, let's look at some of the key areas that Hyper-V has evolved in the past couple of releases. So we'll look at that and also look at some of the needs and challenges that customers are experiencing that we can solve with Windows Server within this introductory section. Now, when we think about virtual machines and we think about virtualization and what customers have been doing traditionally and what kind of needs they've had, as we go forward and customers are growing in confidence virtualizing their low-hanging fruit, those workloads that perhaps aren't as mission critical, now they're starting to evaluate those next set of workloads, the workloads that are perhaps a bit more important to the business, the line of business applications, the big databases. And those are the kind of virtual machines where the demands and the resource requirements are bigger. So there's a need for bigger, faster, more highly available, if these are important workloads for virtual machines. They need to be up as much as possible. But at the same time, we don't want to restrict and lock in those virtual machines to certain pieces of hardware. We want flexibility to move those virtual machines around the infrastructure as much as they can to meet changing business needs, business demands, changes in hardware perhaps. We need to be able to move forward with the area of storage and networking. Think about a request for a new storage LUN. How much effort and work and how many teams are involved in provisioning new storage LUNs or new networks for isolating key test workloads or new dev workloads that are actually being deployed in the environment? How do we manage all of that? How can we simplify that? In addition, we talked about flexibility before. We want to be able to remove any limits around moving virtual machines around that infrastructure. No longer do we want to be tied to moving virtual machines to pure clustered environments. And we'll look at some of the ways that we've solved this in Windows Server 2012 and now subsequently enhanced in R2 as well. And we also want to make sure we're ahead of the curve in terms of embracing hardware that customers are buying today. If a customer buys a new top-of-the-range, state-of-the-art piece of server hardware or storage or networking hardware, the operating system needs to be able to take advantage of that, to be able to bring out those capabilities and enhance the virtualized platform as a result. And that's something that Hyper-V in Windows Server 2012 R2 delivers considerably. When we think about some of the challenges that customers are facing, all of these needs, they're not free. They come at a cost. But customers are being challenged to keep costs down. So how can we deliver more value in the products that power that infrastructure? That's a core fundamental part of Windows Server 2012 and especially now in R2. And it helps us to take advantage of the hardware, the big servers, the big pieces of storage, and protect those investments that customers are making and have made in the past. But there's also challenges around multi-tenancy, particularly with service providers and large enterprises who need to act like service providers to deliver capability and platforms to their business. And in that respect, we need to make that easy. We need to make that possible with Windows Server and Hyper-V. And again, that's something we've made easier and more streamlined in Windows Server 2012 R2. But what did it take to get us here? Where have we come from with Windows Server and Hyper-V specifically to get to this point? Now, before Windows Server 2012 R2, there's been a number of releases of Hyper-V. If we think back to 2008, June of that year, in fact, Hyper-V actually was made available as a beta in January of that year when Windows Server 2008 shipped. But actually, fast forward to when Hyper-V was released in that year as the final RTM code, that was June of that year. And that was Hyper-V as a role of Windows Server 2008. And there was a number of key capabilities that were introduced there. High availability, a good scalability and performance figures, and a migration capability to move virtual machines around. But things really accelerated forward as we moved down that timeline. However, later in that year, in October, we actually launched something called Hyper-V Server. Now, not many people realize what Hyper-V Server actually is. I mentioned earlier Hyper-V was a role of Windows Server. So there's a purchase of Windows Server required to tick the Hyper-V box to enable it as a role of the OS. But with Hyper-V Server, we took all of the Hyper-V goodness, all of the Hyper-V capabilities, and delivered a standalone free version. However, it didn't have some of the clustering capabilities of the Hyper-V with Windows Server version, so it was really suited to test and dev and lab environments, but it gave good performance and good scalability. Fast forward around about 12 months to 2009, and we introduced the R2 wave. The R2 wave for both Windows Server 2008 Hyper-V and Hyper-V Server. So both of those versions got an R2 update. And that brought them not only feature parity with one another, so the Enterprise edition of Hyper-V in Windows Server was used as the basis for Hyper-V Server, so they were aligned from that perspective. But they were also enhanced with a number of key capabilities that really drove Hyper-V adoption at a much higher rate. Capabilities like live migration to move virtual machines around was included at no cost. More flexibility around the SAN storage, so with cluster shared volumes, the ability to place multiple virtual machines on a reduced number of LUNs from the SAN to provide more streamlined administrative and better SAN utilization. When we think about moving virtual machines between slightly different processor architectures within hosts, that processor compatibility mode enabled us to do that. This isn't Intel to AMD migration or vice versa, but more of a moving virtual machines while they're running between hosts that have slightly different processors, maybe the same family, but slightly different steppings, for instance. And when we think about some of the storage enhancements, we introduced a capability where I could hot add storage, virtual disks, to running virtual machines, giving administrators more flexibility and more ease of management for virtual machines without having to take them offline to perform that common task. And there were a number of other performance and scalability improvements as well that really, as I said earlier, enhanced Hyper-V's adoption and awareness in the market as more and more people became interested and started to deploy in different environments. So it was a real big step up. But we did launch a service pack not long after. And the service pack, traditionally, service packs just bring hotfixes, patches, roll-ups, and the like. But this particular service pack brought two key capabilities for Hyper-V specifically. The first was dynamic memory, which is a result of engagement with customers and asking what kind of capabilities do you need and do you want from your virtualization platform. And whilst they were extremely happy with the performance of Hyper-V and the scale, they wanted to achieve better levels of density, but without sacrificing performance. And that's where dynamic memory came in, allowing us to, as we'll see a bit later on, flexibly maintain and manage that virtual machine's memory between an upper and a lower limit, so that when the virtual machine was quiet or idle, we could reclaim memory and give it to other busy virtual machines. And that allowed us to scale that host more effectively, getting a greater level of density and achieving a better return on investment on that same size hardware. And the other additional feature that was introduced was something called Remote FX. And this was specific to the VDI environment, the VDI virtual desktop infrastructure, where we're effectively allowing a customer to utilize physical GPUs, so graphics cards, inside the Hyper-V hosts and present them through to the virtual machines, where those VMs can share a physical adapter between multiple VMs, and they'll see within that VM a much more rich and powerful graphical experience, which is really useful for high-end graphics design or CAD type applications that were used in a virtual desktop environment. Outside of remote effects, if you didn't have that graphical capability, accessing those kind of applications and workloads in a VDI environment could be quite painful and slow. But remote effects really started to change that. And that brings us forward to the launch of Windows Server 2012, which last September really brought in a huge amount of capability for Hyper-V. Many of these capabilities we're going to explore today because they've been either enhanced or improved or supplemented with additional capabilities in 2012 R2. So you'll learn a lot about both 2012 and R2 in this presentation. In terms of scalability, as you'll see the numbers shortly, the scalability went through the roof, allowing customers to run on the biggest pieces of hardware and run the biggest virtual machines. Not just the biggest host, but also the biggest clusters. So when you're scaling out the infrastructure for resiliency, huge scalability for the clustered environment, unprecedented and market leading from that perspective. When we think about measuring and managing resources, features like resource metering allowing us to capture the metrics associated with virtual machines, and quality of service allowing us to control and manage resources such as bandwidth available to certain virtual machines can be very, very useful in the virtualized environment. There were significant enhancements around migrations, so more flexibility around moving virtual machines around the platform, and we'll touch again on some of those in this session today. And when we think about some of the other integration points with hardware vendors, the hardware offloading storage-related technology, network-related technologies, enhancing the performance, the overall performance of the virtualized infrastructure through integration with our hardware partners. Think what I said before about the needs and the challenges that customers are facing. They're looking to better utilize their existing hardware investments and their new hardware investments, and Hyper-V and Windows Server is right there to take advantage of those particular investments. And finally, when we think about how we start to deliver new networks, how we tend to deploy new networks, it's typically a complex task. But with network virtualization, we're aiming to simplify that and enable you to streamline the deployment of networks within your environment without the need to use VLANs. So really introduces some compelling capabilities. And then finally, for DR, Hyper-V Replica was an in-box capability introduced in 2012, streamlined and improved in R2, that enables IT admins and customers to effectively replicate their virtual workloads, their virtual machines, from site to site at a VM by VM level with no need for any specific hardware or other third-party software to handle that replication. It's all in the box with Windows Server, and we're going to learn more about that as we go along. But as we start to break down this particular group of or modules, this is how we're going to slice the content. We're going to look at, initially, scalability and performance. We're going to look at some of the key scale numbers and how we derive those high levels of performance through some of the features that are within Windows Server 2012 R2. Then we'll start to look at security and multi-tenancy, along with flexible infrastructure. So how we can start to provide not only an isolated, secure platform for those mission-critical workloads, but how we can move them around, how we can run multiple workloads, not just Microsoft workloads, but other workloads as well. And then as we start to progress forward, we'll look at the HA, making things resilient and protected in the event of local and site failure. And then finally, just some of the key capabilities and features that just make virtualization better, as I said earlier. There are 5 core areas of focus, and we're going to split those up as we go through the course. So without further ado, it's worthwhile now looking at the scalability and performance specifically. And when we think about scalability and performance, we're thinking about how we can enhance an infrastructure in such a way that delivers the biggest workloads for those customers who are cautious or not quite confident of virtualizing their biggest workloads. Yes, they've virtualized that low-hanging fruit, they've virtualized those smaller workloads, those less critical workloads, but now they're thinking about the next round, the tier 1 workloads. And to do that, you need a virtualization platform that's scalable, that can handle the highest levels of performance at every level of the stack, not just CPU, but also memory, disk, network, and so on. We want to enable that through Hyper-V. And there are a number of key areas that we think about when we think about Hyper-V and the kind of challenges that customers are looking to do. And we alluded to some of these earlier on, all up from a server virtualization perspective. When we're thinking about scale and performance, customers are looking to run those most demanding applications with the highest levels of performance and scale. Those big databases, those big CRM systems, those big web platforms that are the social media that are powering lots and lots of users accessing from applications all over the place. Big data, virtualized big data appliances, for instance. And we also want to make sure that any resources we make available are optimally configured, that we provide a highly available, optimally configured, resource-controlled environment so that certain virtual machines or certain workloads, whilst they get what they need, they're not consuming the entire amount of capacity that we have. That's important because we don't want to lose performance on other workloads just because one workload is busier than others. We need to provide that guaranteed level of service. If you're a customer who's got a web workload, or you're a service provider who's delivering out web virtual machines to your tenants, your customers, how do you ensure that you can give a consistent level of service for those key workloads and applications? And some of the capabilities that have been introduced within Windows Server 2012 R2 and Hyper-V can really unlock that control. And then finally, the customer's made a big investment in hardware. You've made a big investment in hardware, in powerful state-of-the-art servers, storage and networking. How can we best maximize that investment utilizing the Hyper-V and the Windows Server technologies that we've got in the box with Windows Server 2012 R2? We're going to look at a number of those capabilities throughout this section that really help to paint that picture. But what have we delivered at a high level? What have we introduced within Windows Server 2012 R2? Well, firstly, as we alluded earlier, huge scalability at both the host, the cluster, and the virtual machine perspective. So you're able to virtualize the biggest workloads on the biggest host systems and take advantage of all of that processing power, that memory, that disk, and so on, that we can really drive those highest levels of performance for the workloads. When we think about high performance, we think about CPU commonly. And a capability like Guest NUMA, which we'll explore in a few minutes, really unlocks higher levels of performance for those high multiprocessor, high memory virtual machines that we're starting to see people create as confidence grows. Thinking about controlling those guaranteed levels of service through quality of service, not just at the network layer, which was introduced in 2012, but now the storage layer as well, which was new and introduced in 2012 R2. There's been enhancements to dynamic memory that enable us to better manage and control the memory allocation to virtual machines. And finally, we'll touch on a number of the hardware offloading and integration points across both compute, but also networking and storage as well. So first up, let's have a look at some of that scalability across the host and the virtual machines and also the cluster, and just see what kind of figures I was talking about and alluding to a little bit earlier. When I say massive, what do I mean? Because we need to be able to run big workloads. There are organizations out there that are running virtual machine or running physical servers currently that need huge amount of memory, huge amounts of processing power. Can they virtualize them on Hyper-V is the question. Have you got the sheer numbers that they need in terms of CPUs and memory support? And Hyper-V in 2012 and R2 delivers. When we look at some of the support for the physical, we look at a physical host with support for up to 4 terabytes of RAM and 320 logical processors. That is massive. If we think about a logical processor, we think about a common shipping server today. A lot of customers that buy servers today are buying 2 processor servers. Maybe, let's say for argument's sake, they've got 8 cores. And in many cases, those cores have hyperthreading. So that's 16 logical processors per socket. So 2 sockets, 8 cores, 16 logical processors, 32 logical processors total. We're talking about a server that's got 320 logical processors here. That's huge. That's 10 times the size of that example that I just gave. That's phenomenally scalable, and Hyper-V supports that scale. We've tested, we're supporting that in production for customers to run their biggest virtual workloads on top. And we also support up to 1,000 virtual machines per host, 1,024 to be specific. Now, do we see that as commonplace today? No. We don't see many customers needing to run 1,000 virtual machines on a single host. You'd need, in the event of a failover, that's a lot of virtual machines that are going to fail over onto other nodes in the cluster environment. But still, we've tested and we support that. We're confident of that delivery. But when we think about the cluster itself, a cluster, if you're not familiar, is a configuration of physical Hyper-V hosts all connected together via network, attached to some form of shared storage, and virtual machines are run on top. And in previous releases of Hyper-V in 2008 R2, for instance, we supported up to 16 physical nodes in a cluster. So 16 connected together with a maximum of 1,000 virtual machines on that cluster. Now in 2012 and 2012 R2, we support 64 nodes in the cluster, so 64 physical servers connected together to some shared storage and networked together, and up to 8,000 virtual machines on top of there per cluster. Now, those of you thinking ahead and said, well, you said we support 1,000 VMs per node. Do I need 64 nodes to do the full 8,000? And the answer is no. You could do it on less, but just because you can doesn't mean you should. You've got to obviously capacity plan your environment accordingly. But that said, you could run 8,000 VMs on fewer than 64 nodes. So we've not seen anybody do it yet, but you could do it. 64 nodes gives you that bit more space, that bit more flexibility, and also gives you that broader capacity for failover in the event of an issue. But that's hosts and that's clusters. But what about the VMs themselves? When we think about the workloads, the big SQL databases, the Oracle databases, the big systems that people are running wanting to run in virtual machines, each VM on Hyper-V now supports up to 64 virtual processors or virtual CPUs and up to 1 terabyte of RAM. So that's a big VM. That's a huge VM. Compare that with the previous release of Hyper-V in 2008 R2, and you're comparing with just 4 virtual procs per VM and 64 gigabytes of RAM. So the jump has been phenomenal. It's a huge scalability improvement and allows customers to confidently virtualize those big workloads. And we want to take a look at that. We want to show you what this looks like in action. We want to give you an example workload and the kind of performance you can see from one of these massive scale-up virtual workloads. So we're going to go into a demo now where we're going to explore some of that scalability. So let's take a look. Now what we have on the screen here is a physical server running Windows Server 2012 R2 with the Hyper-V role enabled. And this is going to help us demonstrate and have a look at some of those key scalability capabilities that are within the operating system and the Hyper-V specific component. So if we open up Hyper-V Manager, which is one of our key interfaces to manage Hyper-V, you'll see we've got a number of virtual machines running on this particular Hyper-V host, and one of them at the top here, DB01, has already got a considerable amount of resource allocated to it. It's not particularly busy at the moment, but it's got a considerable amount of memory that's been assigned to this particular virtual machine. 64 gigabytes of RAM have already been assigned to this VM. However, it's actually running with dynamic memory, which you can see at the bottom, enabled. So once the virtual machine calms down, because it's recently started up and it realizes it doesn't need that extra memory, Hyper-V will take memory away from that virtual machine and it will go down closer to what the demand is for that particular virtual machine. But at the moment there's no contention on the host system, so Hyper-V is not necessarily in a rush to remove memory from that particular virtual machine at this time. Now if we look at some of the other characteristics of the host, if I first minimize Hyper-V Manager and open up some of the system properties, you'll actually see that this system has got 4 sockets, so 4 physical processor sockets, and it's got over 200 gigabytes of RAM. But that's pretty scalable, but it's by no means close to what Hyper-V supports in terms of a host physical system. As we saw in the slides, Hyper-V supports up to 4 terabytes of memory, so really we're only just scratching the surface with what Hyper-V is capable of. And if we look and minimize here and look at Task Manager, and look at the CPU utilization overall of the host, you'll see there's a relatively low amount of utilization going on this particular host system, even though there's a number of virtual machines, but they're not particularly active at this time. And that's showing the overall CPU utilization of the system, the host system. But if I right click and I change the graph to our NUMA nodes, we'll see that our host system is split into 4 NUMA nodes. Now we're going to learn a bit more about NUMA nodes in the slides very shortly, but NUMA nodes aggregate and collect and pool CPU and memory together to enhance performance of certain workloads that execute on those particular NUMA nodes. And we'll learn more about that in the slide shortly. But if I divide this graph and change the view again to look at logical processors specifically, we'll see that actually, those of you that can count really quickly, will see there are actually 80 logical processors running on this system. This is a 4-socket, 10-core system that gives you 40 cores, and each core has got hyper-threading enabled, which gives us 80 logical processors. But think back to the slides we saw earlier. Hyper-V supports a system that's got 4 times the number of logical processors as this one has. So huge scalability. Now that's enough about the host scale. Let's have a look at the virtual machine scale specifically. And what we're going to do that is we're going to open up a virtual machine connection that we've already got open in advance, and you'll see that this particular virtual machine is our DB01, that one that was pretty busy from a memory perspective at least earlier on, running on this Hyper-V host. And what I'm going to do is open the task manager within this particular virtual machine. And you'll see that actually this virtual machine has been allocated 64 virtual processors by Hyper-V, or by the administrator, which in this case is me. 64 virtual procs. This is the highest scalability we can provide to a virtual machine from a CPU perspective, and you'll see some of those logical processors are ticking along nicely, but the key point here is we can drive the highest levels of performance for key enterprise workloads running in the virtualized environment, with support for up to 64 virtual procs across the board, not just in our top editions of Hyper-V, but in all editions. Hyper-V with Windows Server 2012 R2 Standard, Data Center, and even the free Hyper-V Server 2012 R2. Now that just gives us a quick view of the processors, and they're not doing a huge amount at this point in time, but let's also think about storage. In terms of massive scale, it's not just about processing power and horsepower. We want to think about data. And if we open up disk management within this particular virtual machine, you'll see it's got a number of disks already attached. It's got a data disk, E drive, it's got a C drive, virtual disk. Remember, these are virtual disks, VHDX files that we'll learn a bit more in the slides later, but these are VHDX files attached to the particular virtual machine. And if I scroll down, you'll see there are a couple of unallocated volumes and unallocated disks at this point. They're not initialized, but look at the size. 64 terabyte virtual disks, and I've got 3 attached here to this particular virtual machine. They've not been allocated yet, but I could quickly provision a volume onto there and start utilizing all of that massive scalability space for my key data-driven applications. And if we look at the settings of the virtual machine from the actual hardware components, we can see that this virtual machine, we'll see we've set the memory settings, and we're going to learn a lot more about memory specifically in the slides a bit later on. But you'll see this VM starts up with 64 gig of RAM. It can drop down if it's quiet to just half a gig, but actually when it's really busy, our Hyper-V virtual machines support up to 1 terabyte of RAM per VM. Now, if Hyper-V detects that this virtual machine is getting busy, and in our host we've only got 220 gigabytes of RAM, or approximately, which means we're never going to be able to give this VM the full terabyte, but certainly in larger hosts we can actually configure and manage the host allocation of memory to that virtual machine specifically, very effectively utilizing dynamic memory and some of the advanced capability we have there. And if we look at processor, we can see that it's got 64 virtual procs. Now that's locked while a virtual machine is running, but I can start to tweak and balance resources across different virtual machines using this weightings. Now if I expand this processor and look at NUMA, this is where I can start to tweak the specific settings from a NUMA perspective. Again, you're going to learn more about this in the slides shortly, around this virtual machine. So NUMA doesn't just exist at the physical host layer, where it's grouping CPU and memory into what are called NUMA nodes at the host level, but it's also presenting a virtual topology for NUMA into the guest, which certain applications that are NUMA aware can take advantage of. Workloads like SQL Server or IIS 8, the Windows Web Server that was introduced in 2012 and enhanced in 2012 R2. Now back to storage, you'll see this virtual machine has got a couple of IDE controllers that have got virtual disks attached, but let's focus on this SCSI controller here, where in fact we've got 3 of our 64 terabyte hard disks attached, so data 2 and data 3. And these are virtual disks that are dynamic, so they're not fully provisioned at the full 64 terabytes at this stage. They're only relatively small at this point in time. However, each SCSI controller can have up to 64 virtual disks attached, and we can add up to 4 SCSI controllers to a single VM. So that's 4 SCSI controllers, 64 virtual disks per controller. That's 256 virtual disks per virtual machine across the SCSI controllers. At 64 terabytes each, that's over 16 terabytes of storage, petabytes of storage per virtual machine, 16,000 terabytes. Huge scalability for big data-driven workloads and applications. That was just a brief run through of some of the key capabilities we've introduced in Windows Server 2012 and 2012 R2 for Hyper-V specifically, to enable you to run your key
enterprise class workloads and deliver the levels of performance you expect. We've looked at huge hosts, supporting the biggest physical systems. We've looked at big virtual machines that aren't restricted by specific licensing models. And also we talked in the slides about clusters, combining these big physical systems together into a cluster of up to 64 nodes with 8,000 virtual machines running on there. So huge scalability, great performance, all in the box with Hyper-V.
Welcome back. Hopefully you enjoyed that demo. A lot of cool stuff just shown, the CPU, the scalability, the performance that we can generate in this Hyper-V environment now in 2012 R2 is just phenomenal. Now, when we think about big workloads, we think about workloads like database workloads. SQL Server is a good example. Big web servers potentially as well. And when we're creating virtual machines that have the huge number of virtual processors, 64 virtual procs, and a huge amount of memory, we have to think about something called NUMA. Now, NUMA in the physical world, NUMA is a hardware topology which takes into account physical CPUs and memory and groups them into nodes. Now, when we look at NUMA in a bit more detail, these NUMA nodes, and if you think about the physical layer on the slide there, on the bottom row there of the diagram, we've got what are called NUMA nodes. And NUMA nodes group together processors, CPU, and memory, as I was alluding to very briefly earlier. And these NUMA nodes, CPU and memory, are related into what you'll call a local node. And if processes are executing on a local node using local CPU and local memory, that's typically faster than if they have to reach across into a remote NUMA node to access and to handle that process. That's obviously on big systems in the physical world. But as we create big virtual machines, we have to think about NUMA in the virtual world as well. And with Hyper-V and Windows Server 2012 R2, we project the NUMA topology appropriately from the host into the guest operating system, into the virtual machine. Now, it's configured by default for you. You can tweak and tailor if you want, but it presents that NUMA topology and the NUMA nodes at a virtual level. So you'll see in the diagram there again, vNUMA node A, vNUMA node B. And what Hyper-V will try to do is we'll try to map those virtual NUMA nodes onto the physical NUMA nodes, so that virtual NUMA nodes aren't stretching across multiple physical NUMA nodes, because that results in a less performance. So we want to make sure that we're aligning NUMA nodes appropriately as best we can to deliver the highest levels of performance. But what kind of workloads can benefit from NUMA? Well, think about workloads like SQL. SQL Server 2012 is NUMA aware. So it can take advantage and run its processes in such a way that is NUMA aware and therefore runs at a higher level of performance, especially when you start to create big virtual machines. IIS, the Windows web server in Windows Server 2012 and going forward, that also is NUMA aware. So we can tweak and tailor IIS as a workload to take advantage of the virtualized NUMA so that we're not sacrificing by going into the virtualized environment. And that's very important. We want to make sure that our workloads can make the intelligent decisions about NUMA and can be optimized based on that configuration and that topology. And thankfully, if you do tweak and tailor and configure NUMA and perhaps you make a mistake and configure something that results in a lower level of performance, there's a nice big button in Hyper-V Manager that you can say, use hardware topology, and it will reset you back to what Hyper-V thinks is the best configuration. And generally, you shouldn't have to change that, but you have got the granularity of control if you feel you can do a better job. But it's in there, it's in the box, it's not something you necessarily have to turn on. It will automatically be enabled if you start to create the virtual machines that would require NUMA to enhance performance. But when we think about workloads, it's not just about NUMA. We also have to think about the workloads that aren't NUMA aware, and what can we do to those workloads to enhance their performance? And how do some of those workloads scale? Have we done any testing, any performance proof points? And the answer is yes. We've worked hard with our partners and our respective teams around Microsoft to actually start to build out some of the performance testing for our key workloads. Workloads like SQL Server, workloads like SharePoint, workloads like Exchange. And what we've put together is a number of reports that are available online on the Microsoft.com website that will allow you to actually visualize and understand A, what we've performance tested, and B, the kind of performance for that particular workload in a virtualized environment running on Hyper-V. Now, it's important to call out and stress that this performance testing was performed on Windows Server 2012 Hyper-V. but the results will be similar but improved for R2 as well as we go forward past launch and we start to release some of those out, those newer reports as we go forward. But just to give you an inkling, an idea of the kind of performance as a minimum that you will be able to expect. When we think about SQL Server, we tested a number of different configurations for SQL Server, but one in particular that we want to call out is around the virtual CPU scalability and the number of transactions we can generate. We performed this test as a follow-up to a similar test we performed on Hyper-V in 2008 R2, where we were CPU limited, vCPU limited to 4 virtual procs per VM. Now with 64 virtual procs, we can scale the performance and the transactions per second through the roof. Not only transactions per second, but the latency was considerably reduced, the response time considerably reduced for that workload as well. And when we tested a configuration of a 64 virtual proc VM versus a 64 core or 64, not 64 socket, 64 core physical server, so we tried to align and apples to apples as much as we possibly could, we saw only a 6.3% difference in performance of the physical versus the virtual. And that's native physical performance versus virtualized performance. So the overhead of virtualizing, which people often perceive as being very high, the sacrifice is very high, just isn't the case. And as we go forward, we're always aiming to strive further and further to reduce that overhead even further. When we think about Exchange, we tested 12 Exchange virtual machines on a single Hyper-V host, and we virtualized 48,000 simulated users on that single host. So that was a number of virtual machines running Exchange, low response times, great number of mailboxes virtualized on that single Hyper-V host. So great scalability. What does this show? What does this prove? Because you would never really do this in production. That's not the point. This proves that Hyper-V, when put under extreme pressure and scale, can handle the demands of an intensive workload. So handling the demand of, in this case, 48,000 simulated users using Exchange standard jet stress tools, but handling them in such a way that meant the read response time was within what Exchange expected as good, acceptable performance. So again, proving out that Hyper-V, when configured optimally, can really scale even under the highest levels of demand. And then finally, SharePoint, where we virtualized over 2 million heavy users at 1% concurrency, so reflecting users using the system at different points in time across 5 VMs. Now that was a SQL VM, an application server VM, and 3 web servers. Now you'll notice that in the graph, the web front ends, there's 1, then there's 2, then there's 3. So when the first web front end was on its own, so there was just 3 VMs running, the web server was saturated, the CPU was saturated, trying to handle all of those users accessing their SharePoint infrastructure. Now, when we added an extra web server, we could scale higher to a number of heavy users, but the CPU burden on those 2 web servers was shared, so it was reduced. When we added a third, reduced further, and we could scale that a little bit more. And those CPU levels were within manageable levels. They weren't at meltdown. But then we thought, well, let's just see what we could push this SharePoint configuration with 3 web servers to. Let's really stress it. Let's see what we can push. Not to 100% CPU across all 3, but to a reasonably high level, around the 80% mark. And all of the details are in the documentation. But we saw the jump to over 2 million heavy 1% concurrent users for that SharePoint infrastructure. And that was using the same database that we tested with SharePoint 2010 on Hyper-V 2008 R2 a couple of years back, where the 3 web server configuration only managed 450,000 users. Same testing, same database, 3 web servers, 450,000 users. Here on 2012, with the additional scalability we can provide, 1 web server did over 1 million. So you can see the jump in scalability that we provided in Windows Server 2012, and that will only get better when we go forward to R2 as well. Now, when we think about performance, we've focused heavily on CPU. We talked about NUMA. We're going to talk about memory and some other areas as we go forward, but what about storage? What are we doing around storage when we think about not just the virtual disks, which we'll come to, but what about the underlying storage infrastructure? Because on the market, becoming more and more available is this concept or this release of what's called advanced format drives. Sometimes some people refer to these as 4K sector disks. And these advanced format drives have a 4K sector size as opposed to 512. And these 512 byte sectors, sorry. And these virtual disks that can run on this platform, new in Windows Server 2012 and R2, are aligned and optimized to take advantage of these advanced format drives. Think about what we were saying earlier about taking advantage of investments in hardware that customers are making going forward. Advanced format drives are going to be one of those investments. They have better performance, better resiliency, better capacity, but the industry hasn't quite caught up just yet. Not all applications and workloads are 4K aware, which means there's going to be an interim period where we need some form of emulation. So we are working with the industry not only to work with the 512E disks, which provide some of the benefits of 4K, but they're not native 4K. But when we get to 4K disks, Hyper-V and its virtual disks run natively. In terms of alignment, in terms of optimization, all of that enhances the performance. So going forward, as we see adoption of 4K drives increase, you're safe in the knowledge that Windows Server 2012, Windows Server 2012 R2, and Hyper-V are right there to take advantage of it. So we can really help you deploy the highest performance workloads in our virtual disks on top of these new 4K drives that provide the increased resiliency, optimized alignment, and better capacity. When we think about that virtual hard disk, yes, it now supports the 4K disk under the covers, which is great, but if you haven't got those, what benefits can you see from just using a new virtual hard disk format that's introduced in this release? And that new virtual hard disk format has a number of key benefits. Firstly, it supports up to 64 terabytes in size. That is a huge increase in scale. The previous round of Hyper-V in 2008 R2 with the VHD file format, so note this is VHDX now we're talking about, but the previous VHD format only supported up to 2 terabytes, which wasn't enough for some organizations. They needed more and they needed increased capacity. Now, if you choose to deploy a VHD on Windows Server 2012 R2, you're still limited to 2 terabytes. But if you choose the VHDX format instead, you can now grow to 64 terabytes. Not only capacity, but better alignment, especially alignment with 4K disks, and optimization as well. So optimized structure, optimized protection against corruption in the event of power failure. So you've got that increased capacity, better resiliency, better performance through alignment. And that's all thanks to the way that the new disk utilizes these headers and logs to optimally align the data within the virtual hard disk structure. So what you're getting is an overall improved performance, which is great for our workloads. And if you've got big databases, big data systems, you've got virtual workloads that are generating a lot of data, you don't have to rely on the less flexible pass-through disks or presenting a LUN directly through from the SAN, for instance, which can be in some cases fairly inflexible. The new virtual hard disks, they've got that portability, they're just a file at the end of the day, so I can move them around flexibly. How easy it is to move a 64 terabyte virtual disk, I mean, copy-paste might take you a while, but you can still do it. You'd need a big USB stick if you were transferring it into one location to another, but there you go. Over the network, might be a bit quicker. But you can do it. The key thing is the capacity's there, the scale, the performance. All of that is in this new virtual hard disk format. And if you've got VHDs today and you're moving them to 2012 R2, you can convert them to VHDX files and then take advantage of the benefits we've discussed. If you want to move them back, you can do that, but obviously it has to be within the 2 terabytes. You know, if you want to move it back to a VHD for whatever reason, backwards compatibility maybe. That's up to you. So that's the virtual hard disk in general, but what else have we done around that virtual disk? What's new in 2012 R2 that enhances that story? Well, something great for administrators, and it's called the Online Virtual Disk Resize. Think about the scenario where you've deployed a VM. You've got the OS drive, happily working away, loads of space on there. You've also provisioned a data drive to that VM. VHD, VHDX, you've provisioned it with, let's say, 100 gig. You've deployed a database on there, and 3 months down the line, it's growing, as expected, but it's growing perhaps a bit faster than you thought. It's a mission-critical database. It's been deployed, it's now being used by the business. What are you going to do? It's running out of space. You need to increase the capacity of that drive to allow for the database to grow. Have you got any options? Well, in Windows Server 2012, you can take the VM down, expand the virtual disk, and then bring it back up, and then extend the volume within Windows, and the database can grow into that space. In 2012 R2, things are a little bit different. We now provide that online virtual disk resize. Now, the name is a bit of a giveaway as to what it actually does, but it allows us to expand the virtual disks that are attached to the virtual SCSI controller. So any of you that know Hyper-V will know there's an IDE controller and there's a SCSI controller that you attach virtual disks to. The IDE controller is used for the boot OS, typically the boot OS virtual disk, and the SCSI controller is used for additional disks. If you've got virtual disks attached to that SCSI controller, that virtual SCSI controller, you can grow and shrink the virtual disk while the VM is running. So with the example of grow, we can select the virtual disk in Hyper-V Manager, right-click, settings, etc. We can grow that virtual disk through the disk manager, and inside the guest OS, it will see, inside disk management, as we can see on the slide, an unallocated amount of space that you would then, as the administrator, expand the volume. That bit isn't automatic. All Hyper-V is doing is expanding at the virtual disk level. So inside the guest OS, it suddenly sees this extra, in this case, 10 gig of space. The administrator would then expand the volume. But let's fast forward and think, well, actually, we didn't grow into that. The database usage slowed down. We added 100 gig extra, so it's a 200 gig drive. We didn't need all of that space, so I could shrink it down and save a bit of capacity if need be. Well, thankfully, in Hyper-V in 2012 R2, we provide that capability, that resize capability, which means I can shrink that same virtual disk back down. But first, I need to shrink the volume inside the guest. And whatever I can free up inside the volume using the core Windows Server tools, I can then shrink from Hyper-V Manager's perspective. But I can they're related. I can't shrink more than what I can shrink the volume inside the guest. So there's the two steps to that shrink process. I shrink inside the guest OS, and then I shrink the virtual disk from Hyper-V Manager. So I've got that flexibility to manage that process. And we're actually going to take a look at that in action. So let's pop over to a quick demonstration to see how online VHDX resize works for both grow and for shrink.
Okay, now here we are back on our Hyper-V host running Windows Server 2012 R2, and the Hyper-V role is enabled. And if we bring up Hyper-V Manager, we'll see that we're looking at DB01 again, so our virtual machine that we looked at earlier when we were looking at some of the scalability and performance capabilities. And I'm going to bring up that particular virtual machine into the VM Connect window. I'm going to minimize Hyper-V Manager in the background, so we can focus purely on this particular virtual machine. And what we'll see is if I look at this particular VM, and we look at the volume within File Explorer, we'll see that this VM, as we saw earlier, has got a number of virtual disks that are attached to it. Some of them are a little bit more full than others. And remember, we didn't allocate the 64 terabyte disks that we saw earlier, and I've subsequently removed them from this virtual machine because they're not part of this particular demonstration. But if we look at data F, you'll see it's a 40 gigabyte virtual disk that's been attached to this VM. And if we have a look at the settings for this virtual machine, you'll see data drive here attached to the SCSI controller. There it is, datadrive.vhdx file, and if I inspect, you'll see it's a 40 gig virtual disk, maximum size at the moment, and it's currently got 260 meg of consuming space in the physical world. Let's say that's the file size. So the contents, there may be nothing on that volume, but that virtual disk is actually taking up 260 meg on the in the physical world. But that's not important for now, we'll close that. So what we want to demonstrate is this ability of Hyper-V in Windows Server 2012 R2 to provide administrators with the flexibility to grow and shrink virtual hard drives attached to virtual machines. So firstly, if I just minimize these settings for a second, remember we've got a 40 gig volume at the moment that's exposed to Windows, and if I bring up disk management, you'll see there we go, there's our data primary partition, everything's healthy, everything's great. Now let me bring up the settings again for DB01, and while this virtual machine is running, while this virtual disk is attached, I'm going to click Edit, and I'm going to be presented with a couple of options that are based on my current situation. So the virtual machine's running, I can do certain tasks. So I'm going to click Next, and you'll see I've got two options, Reduce or Expand. So I'm going to go for Expand. I'm going to go Next, and you'll see here the current size is 40 gig, new size, let's make it 50 gigabytes, and remember we can make a max of 64 terabytes. We'll go Next, and we'll go Finish. Remember, all of this I could do through PowerShell as well. I'm just a GUI kind of guy, so I'll go OK, and that should now if we do a rescan of disks within the virtual machine, I should see that I can extend my volume. But there we go. I can extend my volume up into that extra 10 gigabytes of space. So next, and finish. And there we go. Now we have a 50 gig drive in the VM, all without no downtime. And there you see, if I do a refresh on this screen, 50 gig. Great. Now, what happens if we want to go the other way and shrink the virtual disk instead? Well, thankfully, Hyper-V in Windows Server 2012 R2 allows us to do that as well. So let's take a look. Now, the first thing I've got to do, I can't just choose the disk and shrink right away without actually doing some bit of work inside the virtual machine to free up some space from the volume. So firstly, let's minimize this File Explorer view. Let's stick in disk management for now and right click the volume, and I'm going to actually click shrink. So this is a Windows operation irrespective of the Hyper-V virtual machine. So it's saying, how much do you want to shrink? How much do you want to take off this particular volume that you've got inside the virtual machine? And I'm going to reduce it by, let's reduce it by 20,000 megabytes. So there or thereabouts, 20 gigabytes, maybe slightly less, but we'll go for that as a round number, and we'll go shrink. And what you'll notice now is we've got 19.53, so I said it was slightly less than 20 gig. We've got approximately 20 gig unallocated now in this volume, and the data drive itself has been reduced to 30 gig. If we bring up File Explorer and refresh, there we go, 30 gig. So all's well inside the virtual machine. We've freed up some space at that level. But now if I click File and Settings for the VM, so looking at from the outside perspective, and click on the data drive, and click on Edit this time, you'll see what commands we can perform. So firstly, I'm going to click again, and I'm going to choose Shrink. Notice that option wasn't there before. This option is here because we have actually got some space that we can free up inside the VM. We've done that step in advance. Before, we couldn't shrink because our volume was already the full size of the virtual disk. So that option is now intelligently looking inside the guest at the virtual disk level, at the volume level, and determining what I can shrink by inside that environment. And I'm going to go next, new size, minimum 31. So that's the size to reflect the actual volume. Remember, that's what we were just saying a few minutes ago? We shrunk down to 30 gigabytes, and that's what it's given us as the option to shrink the actual virtual disk down to. So I'll go next, 31 gigabytes approximately. We were slightly over 30 in our final remaining volume size. So I'll go finish. We've freed up a bit of space. I'll click OK, and now inside the guest operating system, I'm going to click on Action, Rescan Disks, and you'll see now the volume size. There's a tiny bit left over where we've got obviously a little bit of more of a round number. So I'll go extend that volume, and we're done. So what you've seen there very quickly in demonstration form is we've actually increased the size of a volume for a virtual machine by adding extra virtual disk space to the VM while it's running, no downtime, and then subsequently we've reduced it down by a certain amount and then reclaimed that by shrinking the virtual disk subsequently, all while the virtual machine is running. And that's new in Windows Server 2012 R2 Hyper-V, and provides IT admins with that little bit extra flexibility, which I think we'll all agree is always very useful. So with that, we'll go back to the slides.
Okay, welcome back. Hopefully you found that demonstration useful. It's a pretty cool and very useful from an administrative perspective capability to help me better administer and manage storage for the virtual machine without having to take it down. That's the key thing. That's the key difference from 2012 Hyper-V, is keeping that VM as continually available as possible. So anything that's online is going to help us do that. And VHDX Resize is a good example of that. But when we think about integration with hardware vendors, we touched on the CPU, the NUMA side of things before, relying on that hardware topology. But we've also done a lot around integrating with our storage partners with a capability known as Offloaded Data Transfer. And this was first introduced in Windows Server 2012, and it essentially offloads capabilities to the SAN, offloads storage-related tasks to the SAN, the storage area network. Think about it. Your SAN, if you've got it connected to some Hyper-V hosts and you want to perform a task that involves moving significant amounts of data from one LUN on the SAN to another LUN on the SAN, surely it would be better to get the SAN to actually move those pieces, those blocks, those bits and bytes on the actual storage array, rather than doing a regular Windows copy via the hosts, via the network, utilizing valuable CPU, memory, network, resources. If the SAN does all the work, that's an improvement in performance, because the SAN can do it at lightning speed, and it doesn't burden our hosts with the processing of that traffic and those resources. So this can unlock scenarios, and if we walk through the process, imagine you're perhaps copying or transferring a large file between two areas of the SAN. The Windows Server OS will actually send a request or a piece of data and information to the storage array to say, look, I want to move this. I know you know where it is. You know where it is. Let's work together and move this, but you can do all the legwork because I need my valuable resources for all of these virtual machines that are running on top of me. So we just send that offload request in the form of a piece of information or data. A token comes back that we share between the Windows Server hosts, and that effectively tells all parties involved what should be happening here. So who should be moving what, where it should be moving from and to. And when that token reaches the target destination, the actual data is moved purely on the SAN. Okay, so without needing to actually burden the hosts with the file copy, we just send the information that we need to tell the SAN what to do using that token system. So we're minimizing latency, we're maximizing the value of our array, so we're maximizing that investment. We're not using valuable CPU and network resources on the hosts. And the more effective and better your SAN is, the faster this is going to happen. Now, it may be that your SAN needs a firmware update to support this, to make this happen, to make this work. It may, if you've not updated your SAN for a while, then you may want to look at updating your firmware, because the ODX capability may only be in later editions or revisions of that firmware for your particular storage array. So check with your storage vendor to see the compatibility and the guidance. Many of our storage vendors are actually producing guidance that's specific to their storage array on the tools you need to install, the configurations you need to put in place to make this work. So that's ODX. ODX, a phenomenal capability to offload certain VM tasks to the SAN to really optimize the performance of that combined infrastructure. So virtual machine provisioning, creation, and so on can be really accelerated. But then we think about, what about an investment in Fibre Channel? ODX will work with iSCSI, it will work with Fibre Channel storage, but we've also innovated in the area of helping organizations connect virtual machines directly to Fibre Channel storage. If we think back to 2008 R2, if you wanted to create a virtual machine, or perhaps more specifically, a virtual machine cluster, so you've got two related virtual machines, and you need some shared disk for that virtual machine cluster, you could only really do that with iSCSI, because that operated via the network. It would work via the host vSwitches down to your iSCSI network. In Windows Server 2012 and now in R2, the virtual Fibre Channel capability enables you, the administrator, to create on your Hyper-V hosts a virtual SAN effectively, and create for your virtual machines virtual HBAs. And these HBAs inside the VMs hook right on to the Fibre Channel storage that's underlying the infrastructure. You don't have to provision those LUNs to the hosts and then map them to the array, to the virtual machine itself. You provision those LUNs and map them directly to the virtual HBA worldwide node and port names of the virtual machine adapters. So you're effectively bypassing the host's visibility of those LUNs and presenting them straight to the virtual machine. And within the virtual machine, you can use the common tools that you are used to using in the physical world, like MPIO tools with the device-specific modules from your storage vendor. So if, for instance, you've got a Dell or a HP or an IBM or a NetApp SAN or an Hitachi SAN or whoever under the covers there on your actual array, and you use their tools on the physical hosts, if you're provisioning Fibre Channel storage through to the guests, you can also use their tools in the guest as well, because they will see the appropriate storage technology directly through from the storage array. It's using that hardware investment, maximizing that hardware investment, opening up a new scenario like guest clustering, and it's allowing you to provision storage specifically to those VMs without needing to expose it to the host. So it keeps things secure and isolated as you want it to be. But one of the added benefits of the way we've implemented Virtual Fibre Channel in Hyper-V is it means you don't have to sacrifice certain other capabilities like live migration to use Virtual Fibre Channel. So the way we've actually implemented it is when you provision a Virtual Fibre Channel adapter to a Hyper-V VM, not only will it get just one address set, so a worldwide node name, worldwide port name, but it will get 2 per adapter. So when you're moving virtual machines around, we're flicking over from address set A to address set B as that host migration takes place. So we're actually ensuring that through that process, when the virtual machine migrates from host A to host B, that it keeps connection through to the virtual machine. So you can see in the diagram here on host 1, the virtual machine is currently writing to the Fibre Channel, or reading and writing to the Fibre Channel array via that particular adapter. When we do the live migration, we start the process off, the config file gets transferred over, we get everything aligned, but we start actually accessing the storage through worldwide name set B on the virtual machine that's been provisioned across. And when we flick over, there's no interruption, no loss of connectivity to the storage. So we've done some clever stuff to make this happen, to make this a possibility. Because what we don't want to do, and you'll see this in more places as we go forward, what we don't want to do is give with one hand. Here you go, here's a great feature, gives you new performance optimization, gives you great capability. Virtual Fibre Channel's an example, direct connection through to the SAN for increased performance. But we don't want to say, well, now that VM is locked to that host, it's restricted, it's no longer agile. That's an example of where that isn't happening. So we've got that flexibility to move the VM around, but also take advantage of the key feature to drive higher performance. When we think about other areas of performance, we think about areas like network. And one of the areas we've really innovated in is something called receive-side scaling, or specifically virtual receive-side scaling. So when we think about the host OS, we think about the Hyper-V host itself and Windows Server in the physical world, RSS is a capability that enables us to better balance the processing of traffic within the physical environment across our processes within our host. Now, if we think about an environment without RSS, we've effectively got a situation where the traffic processing is being handled by one CPU. So imagine that the main CPU on the system, CPU 0, that's the one that would get burdened with processing and managing that traffic, that network traffic. And that means that one CPU can run really hot and the others not so much. But with RSS in the physical world, when packets come in, we balance the processing of those packets and that traffic across the different nodes in the system. So we get a more optimally configured system. It helps us maximize our resource utilization, especially as we go to 10 gig, 40 gig, 100 gig network systems, because the amount of traffic coming across those is phenomenal. And we need to balance the processing of that across the CPUs in the system. But then we think about virtual machines and VRSS, virtual RSS, and a virtual machine that's got multiple virtual processors. Similar kind of situation where we don't have VRSS enabled. When there's a lot of network traffic to and from that virtual machine, that first virtual processor gets hot. But when we introduce VRSS and we enable that within the properties of the virtual network adapter within the VM, which is new in 2012 R2, we effectively balance all of that processing across the virtual NICs themselves. And that is reflected in the processing at the physical layer as well. Because remember, the virtual NICs have to map onto physical NICs as well. So if we're balancing things across the virtual NICs, they're going to be more balanced again across the physical NICs in the system as well. So we're able to overall, at a holistic level, balance traffic more effectively within the virtualized environment. And you'll learn more about that in the networking MVA course as well. But what else have we done? Well, we've been busy with VMQ as well. This was introduced in Windows Server 2012 and has been streamlined for Windows Server 2012 R2. What this effectively does, if you think about VMQ and dynamic VMQ, is overall the goal of this is to increase the efficiency, similar to what we saw of RSS, efficiency of network processing of the Hyper-V hosts. So this isn't really a virtual machine thing per se. It's only going to impact the host, but that host is under pressure from the virtual machine. So it's all related in one or two. So if you've got VMs that are generating a lot of traffic and burdening the host, again, VMQ can really help. So imagine we've got a Hyper-V host Without VMQ, and remember this is a hardware innovation, VMQ is a hardware specific capability on Intel, Broadcom, NICs and so on that we can take advantage of. It's a tick box that we can turn on. And you only really want to turn it on for your virtual machines that are high network intensive virtual machines. But you'll see the Hyper-V host without VMQ capabilities, that CPU gets hot. But a host that with VMQ, the physical NIC, so remember this is a hardware offload capability, creates virtual network queues, hence the name VMQs, for each VM to reduce host CPU cycles. So we're offloading a lot of the processing to the NIC itself, which has this VMQ capability. So the virtual machine will balance across the different CPUs and utilize its own hardware offloading to better manage and process that traffic more efficiently. But with dynamic VMQ, which was introduced in 2012, we effectively balance that more efficiently. So we're dynamically allocating cores on the fly. So as we see traffic increase or decrease from different virtual machines, we're balancing this with this rich animation. As you can see, the CPU is going up and it's going down. It's flexibly balancing across the different CPUs in the system. What does this mean in general? Well, as the title on the slide says, increased efficiency of network processing, but utilizing the physical hardware within the system, so utilizing the physical network cards within that system. And sticking with networking, when we think about offloading, when we talked about virtual fiber channel before, that was a direct connection from the VM through to the SAN effectively. So a more direct connection, bypassing certain software stacks that would normally be present with a virtual disk. Similar kind of thing with what's called single root IO virtualization, or SRIOV. With SRIOV, we're effectively integrating again with network vendor hardware, so an SRIOV capable NIC is required, as is SRIOV capable BIOS. So check your system BIOS, it may need an update, a firmware revision. But we have essentially, instead of the virtual machine utilizing the synthetic network stack, which it does day to day, so the virtual machine's traffic is going via the synthetic network adapter inside the VM, down through the extensible switch, the Hyper-V switch, which we'll learn about later, out through the host network adapter. Instead, we'll turn on, for that virtual machine and that VNIC, we'll turn on SRIOV. And instead, the virtual machines utilizes a physical representation. It's called a virtual function. So effectively, the SRIOV physical NIC has a number of these virtual functions that it can pipe into the virtual machine. That's probably not the correct term, the technical term. Place the virtual function inside the virtual machine, and the virtual machine will use that path for its traffic. So you can see from the diagram, it provides actually a very useful representation. The traffic is no longer going via that synthetic NIC, it's actually going via the virtual function, which bypasses the Hyper-V extensible switch and some of the other processing that goes on, and provides, just like that virtual fiber channel example before, a more direct connection from virtual machine through to the physical NIC and out. What benefit does that give us? Reduced latency, reduced burden on the CPU for traffic processing, increases the throughput, so we get a more native throughput from that virtual machine out. The virtual functions are limited in number. It's not an unlimited number. It depends on the SRIOV NIC in question. Some NICs may have 4, some may have 10, some may have lots more. It just depends on the NIC. So check with your NIC vendor. But if I was looking for buying network hardware now, I would certainly be looking at VMQ and SRIOV capability as we go forward, because they're going to become increasingly important to drive down latencies, increase throughput, increase performance for key network intensive workloads. And again, remember we talked about Fibre Channel before as supporting live migration? The cool thing is SRIOV also supports live migration. But how? If that virtual machine has a virtual function that's tied to the physical NIC in host A, how can it get to host B and still have that virtual function? Well, what happens is, when we initiate the live migration, the software stack, or the network path that we were using, virtual function down to SRIOV NIC, we revert back to the old synthetic stack. So we go back to Hyper-V's traditional networking stack. We move the virtual machine, so there's no outage to the virtual machine. We're still able to communicate with that through that synthetic network stack. And when we reach the target host, if that virtual machine is now on a host that has SRIOV capability, we'll put the virtual function back in the VM and the traffic will carry on as it did before. If it's been targeted if it's been placed on a host that doesn't have SRIOV, or there's no virtual functions left on the SRIOV NIC, then it will just carry on down the software stack. So either way, whether you end up with SRIOV on the target VM or not, the network traffic is still flowing. That's the main thing. We can move virtual machines around with the SRIOV capability, which is awesome and different from our competitors in this space. So cool stuff around SRIOV. When we think about memory, we touched on earlier, how can we increase the density from a virtualization perspective? How can we increase the levels of virtual machine, the number of virtual machines we can achieve on a single Hyper-V host? And in 2008 R2 SP1, we introduced dynamic memory that enabled us to balance the memory given and taken from running virtual machines depending on what they were doing. So I could assign a minimum and a maximum memory to the virtual machine, and Hyper-V would just manage throughout that VM's lifecycle how much VM memory that VM had at a particular point in time. But it didn't really give the administrator much control. For instance, as soon as I started that VM with dynamic memory, that was it. I couldn't change those figures until I shut down the VM again. So if my VM was maxed at its maximum VM memory that I'd defined, I had to shut the VM down to increase the maximum. In 2012 R2, however, we've introduced a couple of new options, let's call them configuration options, to enable that administrative experience to be a little bit more streamlined. This was introduced in 2012 and is subsequently in R2 as well, where we allow a minimum memory to be set and a startup memory. So firstly, the administrator can increase the maximum memory without a restart. So while the VM is running, if the VM had been set with a maximum of 4 gig, we could increase that. So we've got flexibility to change that maximum and minimum configurations. But we've also introduced the ability to set up this startup memory. So for instance, I could set a VM that starts with 4 gig, because when it starts, we don't want it paging to disk if it's got a load of services that it needs to start up. So startup RAM 4 gig. But I know when this VM goes quiet, it only needs a gig. So we'll put minimum at a gig. But I also know when this VM gets really busy, it needs 8. So I'll put maximum at 8. So startup 4, minimum 1, maximum 8. And Hyper-V will manage that from that point forward. If I need to increase from 8 to 10, the maximum, I can do it on the fly. So hot out of memory is effectively in Windows Server 2012 and now in R2. So it enables me to flexibly manage that through a ballooning mechanism, the memory associated with each of the virtual machines. But dynamic memory is something I have to turn on. It's not on by default, but it is in the wizard that I can enable it. But aside from dynamic memory, there are certain scenarios such as a node has failed, a physical cluster node has failed, VM is restarting on the next available node in the cluster, but that host, is already under contention. Do we have enough resource to get this new failing over VM started up at least? And that's where smart paging comes in. So if you've got a situation where a VM is restarting after a failover and there is no physical memory available, we can utilize what we call smart paging, so physical disk, to act as a temporary, and that's a key call out. It's not designed for long-term use. This is a temporary pool of, let's call it memory, even though it is underlying disk, to effectively get that VM started so that it can reclaim memory from other virtual machines that are running that may be lower in priority to enable this failing over VM to start and get running. So it's a reliable way to keep a VM running when there's no physical memory is available, to get that VM running. But performance is degraded as disk is a lot slower than memory. So we can see in the diagram here, startup memory, yep, that increases. The paging file provides that additional memory for startup. That smart paging file provides that additional memory, even though it's disk, for that startup. But we remove it after the virtual machine is restarted. So we're not relying on it long term, it's temporary as we said. So we set up that VM, we set the smart paging location. SSD may make a slight difference, but remember, it's only for a short period of time, but it's going to help you in the event of a failover certainly to get more VMs back up and running, and then Hyper-V will reclaim memory quickly from other VMs that are lesser priority and give them to these new starting VMs. Now we mentioned earlier an important part around scalability was managing and maintaining expectations. Managing and maintaining scale at a consistent level. But to define that, we also need to understand what we're consuming. And with Windows Server 2012 and R2, we've actually delivered something known as resource metering, because we know that resources are limited. We know how different workloads operate, and we know that we need to provide that consistent level of service. So we need some way of tracking all of the different metrics associated with virtual machines. And resource metering is a capability that allows me to, once turned on, effectively control and manage and maintain the resources associated with the virtual machine. So I can track the usage, I can aggregate all of the data associated with CPU, memory, disk, network, and now in 2012 R2, the storage IOPS, the average storage latency, the average storage consumption, both read and write, the average storage IOPS. I can collect all of those different pieces of information and I can pipe them into, using PowerShell, pipe them into Excel or a CSV or some kind of system that would present a dashboard. That's not in the box in 2012 and 2012 R2, but I would have to use PowerShell to aggregate and collect that information and present it out to a suitable system. It doesn't matter if I move the virtual machine around, all of this information goes with the VM where it goes. So I can establish resource pools and start to track all of this information. And if I'm a multi-tenant environment where I'm trying to track usage, both incoming, outgoing, on a VM by VM basis, I can manage all of that. So I can start to track those different metrics and perhaps build chargeback mechanisms from those. So I can see that customer X has used in this month X amount of CPU, X amount of disk, X amount of memory, and so on over this month. And I can create a billing plan based on that. But to reiterate, we're just collecting the metrics. We're not actually providing the billing mechanism within Windows Server. That's something that our partners, our customers can build directly and provide as an extra solution. But as I said earlier, controlling those resources becomes very, very important. So we know how to measure through resource metering, but let's say I've got that example of that really noisy web server. I'm a hoster, I'm a service provider. I've got 100 customers in my environment, each with one web server. But somebody has just started up the next Facebook, and we're thinking, okay, this VM is hot. The bandwidth is phenomenal. And it's really using our limited pipe, because we don't have an unlimited network pipe, but all of it seems to be going to that one VM. And they're getting a lot more than they paid for. And my other customers, my other 99 VMs, who unfortunately aren't as entrepreneurial as this particular person, haven't quite got as much bandwidth as they're paying for. So with quality of service, I can start to put caps and also minimum bandwidth levels on my virtual machines from a networking perspective. And I can do this either strictly, so I can say, you know what, you've got a max of 100 meg, 50 meg, 25 meg, or a minimum in the same way. And I can do this relatively. So I can say, you know what, this is high priority, it's got a weight of 60, this is normal, this has got a weight of 40, this is low, this has got a weight of 20, or whatever, however I want to define it. But I've got the opportunity to deploy both minimum and maximum specific bandwidth on a NIC by NIC basis, and it helps me to enable fair sharing. That's the key point, which really helps me control and give a consistent level of service, because I can say to my other tenants now in my environment, well, Mr. Entrepreneur over here who's got this high-end web application, you know what, he's only going to be able to use 100 meg of bandwidth unless he starts paying for more. Whereas you guys, you've also got the same cap, but you're also going to be guaranteed 50 meg. So you're never going to go hungry in that respect. So we've really got that opportunity to define those different levels and provide a consistent level of service, whether you're a service provider, an enterprise, whatever it may be. We can define this through software, or if you're utilizing hardware that has data center bridging support, we can integrate with that as well. So there's multiple mechanisms that make it very, very powerful. Very, very useful capability. And this was introduced in 2012. But in 2012 R2, we've gone one step further. We've gone beyond just networking, and we're now looking at storage. So imagine the same scenario, but in this time that entrepreneur who's got driving the web traffic has got a database that's in that virtual machine, and it's getting hot. Hot so much so that the data virtual disk, the IOPS going through to the virtual disk that are stored on our SAN, where all of our other virtual disks are stored, is going through the roof. Phenomenal performance, but at the sacrifice of all of our other users. With Windows Server 2012 R2, in the similar way to what we had before with network, I can specify on a virtual disk by virtual disk basis a cap for that particular virtual disk in terms of IOPS or megabytes. So I can say, you know what, you're going to be restricted to X. And X in this case is 500, drops down, restricts or provides a manageable expectation of their maximum. And if they want to pay more, if I'm a service provider, then I'll increase that limit. But this accounts for incoming and outgoing IOPS, and it's a VHDX by VHDX basis. So I don't have to configure it for every virtual disk. I can configure it for just specific virtual disks if I want to. But it does prevent specific VMs from consuming all of the IOPS within the environment, which is important if you're providing a managed service or a multi-tenanted environment, but equally if you're providing an enterprise where you've got a lot of virtual machines sharing that same storage. Now this supports dynamic, fixed, and differencing virtual disks. So you've got that flexibility to specify on multiple different levels. And it's very easy to configure, as we'll see now in a demonstration. So let's take a quick look at the quality of service and the impact that that can have within our environment in controlling some of the resource usage within the virtual machines. So let's take a look.
Okay, so what we have on the screen here is our familiar DB01 virtual machine, and that's running on our Hyper-V host that's running Windows Server 2012 R2. To explore some of these new quality of service capabilities, I'm going to bring up the settings of this particular virtual machine. So here we go in Settings. And firstly, I'm going to scroll down to the network adapter. And you'll see this particular virtual machine's got a single network adapter, virtual network adapter. And for this VM and for each VNIC within the VM, I can tick this box and enable what we call in the UI as bandwidth management. And you'll see with bandwidth management, I can specify explicitly a specific number of megabits per second for the minimum and maximum bandwidth for this particular virtual machine. So I may say that this particular virtual machine is restricted to 50 megabits minimum, which means under contention, this particular VM is always going to get a minimum of 50 megabits, which is useful for me to provide an SLA or an expectation to a workload owner who's using this particular virtual machine. But for the maximum bandwidth, I might say, well, you can only use 100 megabits per second, which means that this particular VM, if it got really, really noisy, it's not going to actually consume all of the bandwidth within our network environment. So this kind of setting does require planning. You don't want to just necessarily go out and set all of your VMs to be identical. You want to model it based on the workloads that are specific to your environment and where it's going to make the most sense. Now that was a feature that was introduced in Windows Server 2012 Hyper-V, so it's not necessarily new in 2012 R2. But one thing to be aware of, whilst we've called out explicitly numbers here of megabits per second, you can also utilize through PowerShell or through System Center Virtual Machine Manager, you can use a relative figure, which means between a scale of 0 and 100, you can say, well, I've got a virtual machine and I'm going to give that bandwidth weighting of 60 and another virtual machine 40. So when there's contention on the network, one VM is going to get 60% and one's going to get 40% of the available bandwidth. So you can slice it and dice it in a couple of different ways. But that lets us explore and understand what happens from a networking quals perspective. But new introduced in Windows Server 2012 R2 was the ability to apply similar kind of quality of service configuration onto our storage, specifically the virtual disks that are attached to the virtual machine. And I'm going to zoom in and double click down on our hard drive here, our secondary, our data drive that's attached to our SCSI controller here. And it's not exposed through the UI, through this particular landing page, if you will, for the virtual disk. But if we expand the little plus sign next to the disk and we see advanced features, you'll see here, like at the top, I can enable quality of service management. And this is very useful specifically to set usually a maximum number of IOPS for the virtual machine in 8K increments. Remember, this is a combination of read and write, so you'll have to again do a little bit of planning to actually think about what's going to be right for that particular workload. But similar to what we saw before with the network, it enables me to specify, and this is very useful in perhaps a shared service provider environment where a virtual machine may start to consume more IOPS than its fair share, which could impact other virtual machines within the environment as well. So being able to set that maximum from a quals perspective on the storage and also on the network gives me, the administrator, the granular kind of control capabilities to deliver a more consistent level of service for our virtualized workloads. And with that, we'll wrap up with quality of service and we'll go back to the slides.
And welcome back. Hopefully you found that useful. It's a phenomenal way to control, in a really easy way as well, the network and the storage quality of service to really enhance and provide a more consistent level of service, which is important in a number of different scenarios. And that really brings us to the end of our first module, our first part, where we've covered a huge amount of scale, performance, density, dynamic memory, NUMA. We've covered a huge amount of capabilities, and we've only just started to scratch the surface. But what can you do next? Well, straight after this, I know you're going to be dying to go and download and evaluate the products. Go ahead, use the links on the page now to go and access the evaluation software, download it, start to use it, start to test out some of the performance for your workloads. Start to think about some of the hardware that you may have invested in or maybe thinking about investing in that Hyper-V can now take advantage of that you just learned about. Evaluate, get trained. There's more parts of this to come. We're going to be looking at security, multi-tenancy. We're going to be looking at flexible infrastructure, high availability, some of the new features that are innovating in Hyper-V. So there's lots more to come in future parts. But there are loads of other courses on the MVA as well for areas of System Center or other areas of Microsoft technology that you can learn about. And finally, get certified. Once you've learned, once you've trained, go out and get certified. Get your certification on this technology and be infinitely more valuable to your business, to your customers if you're a partner, and to your own colleagues within your environment. That wraps up this session. We've gone through a lot of information. Hopefully you found that useful, and please join me in the next part where we're going to look at security and multi-tenancy. Thanks very much for your time.